I'm going to show you how you can recursively calculate factorials in Java. Now let's get started. First, I want to go over a quick definition of what a factorial is. So start with me on line 5. So let's say we have n, which is a positive integer, which is just a counting number. We'll define n factorial is this exclamation mark over here, as the product of all positive integers less than or equal to n. So that means this mathematical expression over here, n factorial is equal to n times n minus 1 times n minus 2, all the way till we reach 1. So a couple of examples are listed down below. So line 10 and below, we have 4 factorial equal to 4 times 3 times 2 times 1, which is 24, 3 factorial equal to 3 times 2 times 1, which is 6, 2 factorial, 2 times 1, which is equal to 2, and 1 factorial equal to 1. There are two things I want to call out here. The first thing I want to call out is with this 1 factorial equal to 1, we're not doing any multiplication here, which is pretty cool. No multiplication, no math. So this is going to help us, this observation is going to help us when we're writing our recursive factorial function. And then there's a second observation I want to make up above here. So we have 4 factorial, which is equal to 4 times 3 times 2 times 1. So another way we can write this is actually 4 times 3 factorial. And the reason we can do that is because 3 factorial, this 3 factorial over here, is the same thing as 3 times 2 times 1, because that's what the definition of a factorial is. So 3 factorial is equal to 3 times 2 factorial, so 3 times 2 times 1, 2 factorial, 2 times 1. We can do this also for 2 factorial. 2 factorial is equal to 2 times 1 factorial, and 1 factorial is just 1. So we're able to generalize this, saying for all n's greater than 1, we can write the following. N factorial is equal to n times n minus 1 factorial. So these are the two key observations I want to make. With 1 factorial, there's no multiplication to do, no math, we just know that the answer is 1. And then for all n's greater than 1, we can break down the problem as just n factorial is the same as n times n minus 1 factorial. N minus 1 being a smaller problem than n factorial. Now let's go to our factorial recursive function that we're going to write. It's going to be a public static function, and we'll have it return an int. I'll call it factorial, and it's going to need an argument, which I'll call number. So there are two things we have to write in here. The first being a base case. The base case is a simple problem, doesn't need to be broken down to solve. And then we have the recursive case, which is something that requires breaking down to solve. And that breaking down process must result in a smaller problem that we know how to solve. So if we're trying to break down the factorial of 10, we can't try to break it down into factorial of 20 times factorial of 25. That seems like a bigger problem that we don't know how to solve. We must solve simpler problems in a recursive case. Now let's start for the base case first. Well, looking at my example, I can think of a simple base problem for my factorial function. It's the case when number's 1. We didn't do any math. It was just 1. The factorial of 1 is 1. So let's write that out. So if someone ever comes to us and says, I want the factorial of 1, I can say, okay, it's 1. So with that if statement, we're half done with the function. Even though this function only works for 1 out of all the positive numbers out there, this is half the code we have to write. So let's now write that else case, which will handle the recursion. So in this else case, we have to handle every single number, 2, 3, 4, 5, 6, any n greater than 1. So let's look at this expression to help guide us. We want to in here return n, which is in our case this function, the number, times the factorial of number minus 1. So this is saying in the case when we have, hey, I want to find the factorial of 4, the factorial of 4, you're equal to, well, 4 times the factorial of 3. So notice we are actually doing what we need to do in the recursive case. We're breaking down the problem. So to try to figure out the factorial of 4, we're trying to figure out the factorial of 3 first. And that problem we're trying to figure out, or the simpler problem we're breaking it down into, it is in fact simpler. It's an easier problem. It's closer to this base case. The number 3 is closer to the base case of 1 than 4. We're getting closer to it every time. So if we were trying to find out the factorial of 6, it would be 6 times the factorial of 5, that 5 is closer to the base case. That recursive step we're taking is closer to the base case than where we started. So the recursive case has to simplify our problem. So let me get rid of this return 0. That was there when we created the function. And let's comment let's remove this comment for now. Sorry about that. So in the first line of this function, I'll also add a print statement to help us understand what's going on. And here we'll say hello from factorial. I'll also print out the number we get as an argument. And that's about it. Let me just add one more print statement over here saying done with the recursion. So once we hit the base case, before I return, I just also want to make this print statement. Now, let's test if our function works. So I want to system.out.println factorial of 4. Let's see what happens here. So I'll run my program. Whoops, seems like I have a typo in this print statement. Let me fix that. And now, let's see what happens. Well, we have 4 hello statements printed out. We have this done with recursion, and then the 24 that I wanted. So I called factorial of 4, got the 24 back, which is good. Our function works. Now let's run through each of these print statements to see what was actually happening. So even though I called factorial once with 4 here, I do see that hello from factorial 3 more times, and that's the recursion in this else statement at work. So let's walk through each line that got printed out. So from my main, I called factorial of 4. I reached this print statement the very first time this function was called, hello from factorial of 4, right here. Then I'll reach this if statement. The if statement's going to resolve to false. 4 is not equal to 1, so we'll hit this else statement. So factorial of 4 will say, hey, I want to return 4 times the factorial of 3. So this function call is going to make a function call to my factorial 3. So where I see this hello from factorial 3, this gets printed out. The number's not equal to 1, so we get to our else statement. It's going to say return 3 times factorial of 2. So we'll go back to the top. It'll say hello from factorial 2. It's not our base case yet, so it needs to recurse one more time. So we'll get back to the top of our function, hello from factorial 1. Then we'll hit our base case, so that's where we see this done with recursion. Then 1 gets returned back. So this factorial 1 will finish. It'll say, hey, I'm done, have a 1. So now the running factorial 2 will say, okay, I want to return 2 times factorial of 1, which is 1. So we'll return 2. Now factorial of 3 will return 3 times 2, which will be 6. Then factorial of 4 will return 4 times the factorial of 3, which was 6, which will be 24. That's how we get to that 24 that got printed out to the screen. So hopefully that helps clear up any confusion around how to recursively solve the factorial problem in Java. Hope that helps, and thanks for watching.